Oh my god!
Look at that!
That is a Dumbo octopus. Just
Out of the blue.
this is amazing. This is amazing. Can we try and?
Yeah, we're gonna try to keep it till.
Oh my god!
Oops.
Oh, please stay with us here for a bit.
Welcome aboard Greenpeace Deep Arctic Expedition. We are now on the research vessel in the middle of the North Atlantic between Greenland and Norway. And this pocket of water is shaped like a banana and therefore called the banana hole. It's international waters, meaning it belongs to all of us. No state owns it. And underneath us here, at several thousand meters, there are an abundance of very special life. We're looking at seamounts, so underwater mountains that whales use to migrate through the Arctic oceans. And also biodiversity hotspot for life, so corals, sponges, octopuses, other strange creatures. And the further down you go along these seamounts, the less life but weirder life we see. But there's also volcanic activity here. So you see hydrothermal vent fields, which is basically volcanic hot springs. This is an area rich in minerals because these hydrothermal vents push out minerals, so we have crusts of minerals. And therefore the Norwegian government want to open up for deep sea mining here. We think this is a bad idea. And we're here to gather evidence of vulnerable marine ecosystems and life here in order to be able to protect it in marine protected areas. We have a number of scientists that will explain some of the specialities on board. But first, I thought I'd show you one of our main tools, Holly. And then we need to go outside. So I need to put on a helmet. So if you follow me here, watch your heads. Beautiful day in the Arctic. Pretty calm sea. It's good for diving. Did you know that we actually know more about the surface of the moon and even Mars than we do about the deep sea? So in many ways, when we go down with our robot to the seabed, it's more like a moon landing, with the exception that we're actually expecting to find alien creatures. So, Holly is an ROV. ROV means remote operated vehicle, and it's basically an underwater robot connected to the surface by a long cable. It's about 4,000 meters, which makes it possible for the ROV to go down to 3,000 meters. I don't know what that is in feet, but it's about 10 Eiffel Towers stacked on each other. This is the ROV shack. So in here, let's have a look. This is where the pilots are steering the ROV. We have a camera here. Hello. So in here they can steer the ROV and its arms. I'll show you the arms. They're pretty cool. So our ROV is called Holly, and here she is. She weighs about 3,000 kilos. She's about 3 meters long and about as high as I'm tall, so about 190. Here you see the arms, the manipulator arms. She has 2 of them, and they can be steered to do all kinds of things. So the scientists can use them to pick up small samples from the seabed. They can also use these coffee mugs to scoop up sediment. They're not actually coffee mugs, but they look very much like a coffee mug, right? To scoop up samples. You also have a light rig here. You need a lot of light because it's pitch black in the deep sea. You have animals who've never seen the daylight. These are the cameras that the pilots use to steer her. And here we have the camera that takes our photos and do the live stream that we're also producing. And here are some other samples. I think they're called Niskin bottles. Yeah, and this one. This is a slurp gun. So it's basically like a vacuum cleaner that can take out sediment for sampling. So let's walk into the wet lab and meet one of the scientists. Watch out, it's a bit slippery on the deck. This is our backup camera, our drop cam. So in case Holly gets sick or damaged somehow, this is our backup. Let's hope that doesn't happen. But it's a good camera also, 4K camera. And these are for water sampling. And this is the wet lab. So this is where all the samples goes when they come up from the ROV. So this place will be occupied by a number of scientists who take the samples, look through them, take photos, and write down the details basically. We're going to meet one of the scientists in here, which is Dr. Ann-Helén Tandberg from the University in Bergen. She's an expert in amphipods. It's these small crustaceans, like shrimp-like animals. Let's see. Hello. How are you doing?
Ooh, I'm all good.
What are we looking at here?
Ooh, we are looking at my favorite amphipod, I think. This is Exitomelita sigina, and they're sitting on a hydrothermal vent that is called Loki's castle. And since everybody knows Loki from the films, right? So when I described the species and named it, I called it Sigyn because Sigyn was the wife of Loki. And they're sitting here and they're making little amphipods.
Yeah, I forgot to say, Ann-Helén actually named many of the new species that has been found in this area.
Yeah.
So why is it important to find new species?
It is important to find out which species are in a system. And to understand the system, you need to really understand which species are in the system, not just that there are amphipods and little snails like those little white dots around the amphipods there, but to understand which specific species are there. And when we haven't been a place before, very often those species are new, especially in groups like, for instance, again, amphipods, because they don't spread with larvae. They have to be where their mom and dad were when they grew up. So they can't spread very far. And then we have, with evolution, very many new species.
And what is special about these, especially these hydrothermal, these volcanic ecosystems?
The hydrothermal systems are super exciting because compared with every other ecosystem in the world, they don't need sunlight as energy. You know, a normal system, you have the sun shining and then you have photosynthesis and the grass is growing and the cow is eating, and then that's sort of the basis of all the energy we have on Earth. But when you go to the hydrothermal systems, the warm water that comes up from the volcanic areas of the seafloor will bring with them things like sulfur and methane and stuff like that, and bacteria will then eat these compounds like methane or sulfur. And then the bacteria will be the basis of the food chain for the rest of the animals that live there. They can even be sitting on the animals. That's kind of crazy. But those amphipods that I showed you, they have them sitting on their gills, so they don't even need to eat. They just, hang out in lukewarm water and don't even need to eat. They do make little amphipods. That's what they do. It's kind of a crazy life. And they're the biggest animals on this hydrothermal vent. They're about this big when they're really big.
And they're basically hanging around in a hot tub and eating without eating.
Yeah, having somebody eat for them.
That sounds nice.
Yeah.
Thank you so much, Ann-Helén.
You're welcome.
I will leave you to it.
Sure.
Thanks. You see, helmet, very important. Okay, we're leaving the wet lab and moving up back towards where we started from, pretty much. Today is a pretty great day out in the Arctic. It's nice water, perfect for diving. It's a bit chilly, as it should be. We actually saw 2 whales passing by just like an hour ago. But I'll take you through a narrow passage here between Holly and the shack. Bear with me. And be careful. So we have 6 different scientists on board, external scientists, and plus 2 Greenpeace scientists, marine biologists. And we're going to go up and talk to one more of the scientists. It's Dr. Paco Cardenas from Uppsala University. He's a specialist in the oldest life forms on Earth. You heard me, the oldest life forms on Earth. And they are deep sea sponges. So he can tell you all these exciting things. I thought when I start started hearing about deep sea sponges, I thought, sponges doesn't sound too exciting. Believe me, they are amazing in many ways. So we're back in the dry lab. It's a lot warmer in here, so I think I'll take off my jacket. And here you see the live studio where we do the live stream. This is Jason. Helmet. You don't need a helmet in here. And over here in the corner, we have Dr. Paco Cardenas from the Museum of Evolution in Uppsala. Hello, Paco.
Oh, hey, hi.
How are you doing?
Very good. I'm looking at sponges.
Yeah, tell me, what's so interesting about sponges?
So sponges are probably one of the first animals to appear on the planet. And therefore they're super strange. They don't have any organs, they don't have any muscles, they don't have any neural tissue. But they are fascinating because they have tried different types of surviving during evolution. And one of those is to have a skeleton completely made of glass. So they're the only animals to have a skeleton made of glass. And I can show you actually a couple of pictures here. The shapes and forms of these little skeleton pieces in the sponge are truly amazing. And they managed to make those here in the Arctic Ocean.
You say they're the oldest animals on the planet.
Mm-hmm.
So meaning older than crocodiles and sharks?
Absolutely. So they probably appeared around 600 million years ago. So for those who know, who've heard of the Cambrian, that's even before the Cambrian, even before all the rest of all the animals appear.
So even before the dinosaurs?
Yes, absolutely. The dinosaurs appear only 300 million years after sponges. So it's quite amazing.
And how do they survive in the deep sea?
So they are filter feeders, meaning that they're constantly filtering the water and eating small particles or bacteria in the water. So they're cleaning the oceans basically. So that's most of the sponges, but there are other sponges in the deep that don't have enough food. And so they've developed another strategy to be able to eat. And these are the carnivorous sponges.
Basically meat-eating sponges.
Absolutely, yes. They catch little shrimps, little crustaceans that stick to their bodies and they are digested by the sponge. And we have a lot of carnivore sponges here in the Arctic Ocean, especially in the deep, because there's not so much food for everyone. So this is a good way to get extra proteins easily.
And why is it important to research sponges?
It's important because since they are the first animals to appear on the planet, it will give us a hint on how animals can appear on Earth, but also other planets. They are also important because they are little pharmaceutical industries in the sense that they are producing a lot of very interesting compounds. They live in symbiosis with a lot of bacteria, and the bacteria and the sponge together produce a lot of chemicals. And these chemicals could be really important cures for the future, for drug leads, for the next pandemic, and so on. So it's very important to describe and explore these sponges also because of their chemistry.
That sounds super interesting. So what do you hope to find here during the expedition?
So we hope to find new species. I'm a taxonomist. That means I name and I describe and I classify species. And I can do that with SpongeBob SquarePants, but I can also do that with new species that I describe.
That's super interesting. So in here is the container where the pilots and the scientists will be sitting during the live streams. Yeah, there's no one here right now, but this will soon be occupied. So yeah, there's one of our live cameras. And this is where we will be sitting and steering the ROV to take us down to the ecosystems, hydrothermal vent fields, and all the exciting stuff we're hoping to find at the bottom of the sea.
This one is not as shy as the bigger one.
He
You
wants
see?
to say hi.
Beautiful. It's a really big one, I would say about
Yeah.
50 or 60 centimeters, even
Yeah.
more.
Look at that. Hello, beauty.
It's just but a different individual. Sea star.
And there's a fish sleeping on top of the rosalid. Oh yeah.
Holding my
and
breath.
Oh, but is that a fish just hanging out there?
Yeah.
Yeah, he's just hanging out there. Look at that. There is another skate coming there, right?
So this is a beautiful shot, this one.
It's a beautiful
Because
shot.
we
Let's
see
just, if
many
it's
of the
possible,
species
yeah.
that we've been describing in other areas all together into a single spot. Sardinia, Bislandorix, some carnivore sponges probably.
It also seems like on the right side it's different to what is on the left side. It looks more like a carnivore on the left. Ooh, Shrimpy doing a show for us.
ID. There you have it. I will write the coordinates. See if.
It looks, yeah, looks interesting.
Yeah. Stuff is but
Somehow encrusting. Ooh, and now a lot of beautiful soft coral coming our way. Yeah, I think they have a good time there. Catching their prey with the little polyps.
So that's the chondrita. Yeah.
The more
You
transparent
can see
one.
now very clearly the
Yeah.
skin.
Yeah, oh, it has like a mucus layer around us. It's not mucus, but it,
Yeah, I think that's just the skin.
yeah. Now you can see the transparent layer very well. Oh, it's, yeah, on the right. It's a bubblegum sponge? Not sponge, coral, I'm sorry. Yeah.
we need to get to the same to the idea what we're doing. So this arm is gonna be just getting close to the specimen, and we're gonna try to get small piece.
We know now the exact location we have sampled, and we know
A little bit.
exactly which specimen.
Shoulder down, arm out.
Well, hopefully it's gonna go down. Yeah.
Lift up.
Is it floating?
That's the question.
Hope it is not floating.
Fingers crossed.
I want to swing the arm around.
Yeah. It's not
Going
floating.
down, yes.
Yeah.
It's in.
Can you place it a little bit?
No, it's coming down by
Oh, yeah.
itself. Let's not play more. See, when we're moving it in, that's perfect. Thank you
Amazing
so
job.
much.
Thank you. Thank you, buddy. Thank you, guys.
So that is our first sample of bamboo coral.
Yeah.
Is it?
I don't know.
He is eating.
Indeed. Yeah.
Or is it, yeah, is it a dead fish?
Yes.
Yeah, it's a dead fish.
Squid.
Dead squid.
Probably, yeah.
Yeah. So look at that.
Calamari.
Yeah. It's lunchtime.
Ooh. Yeah, lunchtime in the deep sea. Perfect. That's perfect. Look at him.
Beautiful.
That mud and sand is a combination of pieces of dead coral and some foraminifera, and as Sergi says, some sponges here and there. This is a very nice still.
Yeah, we just it up. It's fine. No, don't worry, because it's quite nice. Fly on.
Okay.
Zooming out.
Thank you, guys.
No worries. I will zoom in here. Very nice.
And so many brittle stars on the sediment. Incredible.
You can see hundreds.
Yes, and the clam
Lovely.
again. It's completely oh, decapod. Little decapod. Move it down.
Yeah.
And another egg. Look at that.
Yeah, on the right,
Oh.
a beautiful skate, Arctic skate.
Now I
egg.
don't know what to do first. So much excitement. Shall we zoom in just straight ahead and maybe have a little still image of this? Huh?
Very nice. Let's enjoy that view.
Yes. This is beautiful.
This is a carnivorous sponge that we collected with the robot Holly during our last dive. It was sitting on a volcanic rock about this size, and we used a slurp to catch it. Now I'm treating it to fix it for the collections for further studies in genetics, but also in its biology. It turns out that this specimen is actually reproducing. So there are small swellings along the branches, which indicates presence of possibly eggs. And so I'm taking little fragments of these branches to study the structure of these eggs, which is currently very poorly known. This is a branching sponge, but along these branches you have little feather-like structures, and these feather-like structures are going to catch little preys, usually like small shrimps that are going to get entangled into these structures. And then once they are trapped, sponge cells will move to the prey and completely surround it and digest it, eat it basically. And once the prey will be fully eaten, those cells will come back to their place of origin. So it's a really cool system.
So I'm trying to find marine invertebrates, worms, and crustaceans that live inside in a symbiotic way with the sponges. So we found a few of them already. And the idea is just to study not just the sponges that we are studying here from different purposes, but also the fauna that lives around and within the sponges.
Oh my god!
Look at that!
That is a Dumbo octopus. Just
Out of the blue.
this is amazing. This is amazing. Can we try and
Yeah, we're gonna try to keep it
Oh
on.
my god.
Oops.
Oh, please stay with us here for a bit.
A deep sea ecosystem is often considered vulnerable because very many of the species are long-lived and don't produce very many offspring. So if something happens, they have a very little restitution availability. Another reason why deep sea ecosystems are considered vulnerable is that they need cold water. Most of the deep water is cold water, and climate change is changing that. So that will be not so cold anymore. Also, very many of the species in the deep sea are small invertebrate species, so not having an internal skeleton. And they very often have an outside skeleton, what we call an external skeleton, that is built from calcium somehow. And this is very difficult for them if the water becomes more acidic, as happens with ocean acidification, which is a second part of climate change as well. So the deep sea, even though it's far away from us, is already now suffering a lot of problems.
Finally!
It's not. This is good.
Yeah,
it's
I'm happy.
really
As long as it's an 8
That's
arms, I'm
its
happy.
own
It's
piece.
beautiful. Bring your friends.
Deep 714.
Oh, it looks so good.
We have now been at sea with the Deep Arctic Expedition for almost a month, together with a group of scientists to explore the Arctic seabed. This is an area less explored than the surface of Mars, and home to some extraordinary ecosystems with Dumbo octopuses, sea spiders, Arctic skates, bamboo corals and sponge gardens, the oldest animals on the planet. But these animals are all under threat from the deep sea mining industry, who are desperate to tear up the seabed for minerals, causing irreversible damages to these ecosystems. We have dived down thousands of meters to gather evidence of vulnerable marine ecosystems in order to protect them. We will then use these findings to push for protection and a global network of ocean sanctuaries and a moratorium on deep sea mining. Join us to protect the ocean and keep the deep safe.